Welcome to the office. We want to take a look today at groups. So let's start off by looking at the definition here. So groups, a group is this thing, a set paired with a binary operation. Now this should look familiar actually, right? This is the same notation that we used for a binary structure. Binary structure. So the only difference between a binary structure and a group is a few details, of course, that follow that we're going to specify here. So a group is a binary structure that is closed under a binary operation. Excellent, right? That's required for a binary structure, I do believe. Such that the following axioms are satisfied. So we have a binary structure that satisfies three axioms. Those three axioms are, so they are denoted as G1, G2, G3. If you wanted to note them as A1, A2, and A3 for axiom 1, axiom 2, and axiom 3, that's fine. Otherwise, we'll see that these are also characterized by differently. That we could easily refer to them as rather. So for all A, B, and C elements of G, we have that A star B star C is equal to A star the quantity B star C. Of course, this is associativity of star. Associativity of star. So I can refer to the first axiom as just associativity of star of the operation here. All right, axiom 2. There is an element E in G such that for all x in G, we have E star x is equal to x star E, which is equal to x. So what we're specifying here is that there is an identity element. All right, so identity element E for the binary operation star. Now we know that the identity is going to be unique. We already covered that for binary structures in, I think, section 2 or 3 maybe. So that result is, of course, going to be carried forward here. And then corresponding to each element of the set G, there is an element A prime in G such that A star A prime is equal to A prime star A, which is equal to E, the identity. So we have inverse elements. So what we are finding here is the inverse A prime of A. So for each element, there is an inverse. So these three characteristics we take or define for us a group. We take a binary structure, and if it satisfies these three axioms or these three conditions, then what we have is classified as a group. So are all binary structures groups? No, not necessarily. And we'll take a look at that in an example in just a moment. So really short videos here. Join me for a couple of examples of groups in our next video.